the recording again. So this is our syllabus of geomorphology. So what I was saying is that this unit 2 of our paper 1 is divided into two part by UPSC, right? One is this remote sensing, another one is geomorphology. So another one is geomorphology. So basically, like there are just 250 marks weightage of paper 1. There are 6 basically units. So every unit will generally have 40 to 45 mark questions, right? So basically this unit 2 is also of 40 to 45 mark question. So this is divided, this 40-45 marks are divided into geomorphology and remote sensing. So from geomorphology you will have around 20 to 25 marks questions only, right? Here also you will have around 20 to 25 marks, right? So this is how you should like prepare, right? You should strategize. One thing, another thing is that in this 20 to 25 marks, generally speaking, you will get one question in compulsory and another question in optional question, and same is the case here. One question in compulsory and another one in optional, right? Maybe sometimes two questions from geomorphology, or sometimes one from remote sensing, or vice versa, right? So this is generally the breakup, how like UPSC is asking question on this. And another important thing about geomorphology is that this geomorphology is actually a very simple yet very important, right? Very simple yet very important unit. Like it is important, it has gained more importance in recent times because it has gained more important in recent time, because if you will see the marks of candidates especially good candidates in last 2 3 years. So you will see that in paper 1 geology in civil services, people are scoring up to 170, or some people have even scored up to 185 marks, right? Last year many students crossed 180 marks barrier. And in paper 2, good students generally score somewhere around like 140 to 155, like. So this is general trend in last 3 4 years. But it can always change, right? So there are some people who score more in paper 2 than in paper 1, but this is general. So basically the thing is, people are scoring very high in paper 1, right? This is out of 250. And in forest also, people do score around 150 out of 200, right? Same here, 150 plus out of 200, right? Especially the topper. So since everybody is scoring very high, these easy chapters like general geology, geomorphology, they gain a lot of importance in this in this paper. And the most important thing about geomorphology is, like, firstly it is linked with our general studies, right? GS geography, it is directly linked with prelims. In prelims, like from last couple of years or maybe 3 4 years, UPSC is not asking questions on landform, but in earlier times before 2015, there used to be 2 to 3 questions directly on landform, right? Landform related to glaciers, landform related to wind and groundwater. So they used to ask, but UPSC is not asking. But this does not mean that they will not ask. They can ask, right? You also have a full chapter, dedicated chapter on landforms and other aspects of geomorphology in NCRT. There is a book. This is GC Leong. You all study this for gender studies. So it is pretty much linked to this, and whatever we'll do in next 5 6 7 classes of geomorphology, it will be relevant for your prelims also, right? If you are happening in 2022, right? So that is the thing. So another thing is that this is relatively very simple, and this is very diagram driven chapter. In each and every question of geomorphology, you will have content to draw multiple diagrams, right? In a single question, you can draw up to, either you can draw one big diagram and 2 3 small, or you can draw 5 to 6 small diagrams, right? So this gives you an opportunity, right? I have my handwritten notes also with me, and I'll share those. You just try to practice a lot of diagram here, right? If you are able to right, draw this diagram in time limit, it will also save your time, and it will give you relatively very good marks, right? And of course it is very simple and very scoring. So this is why this is very important, geomorphology. And same is the case with remote sensing, right? So this is the thing. Another thing is, like, based on this previous year question analysis, the two most important topic for exam purpose is these. One is this basic concepts and another one is related to landform, right? So suppose this is our syllabus. This is our syllabus. So what I mean is these topics are the most important topics. One is basic concept of geomorphology, right? Another one is related to landforms, right? So this basic, and third one is this morphology in relation to structure and lithology. So these are the most important topics, right? 95% of the question will be from these topics, right? So basically this basic concept of geomorphology and this morphology and its relation to structure and lithology, these are same, and this is also same, right? So I have clubbed all these three topics together and we'll study it in a very together basically. And then so basically this is the thing. Then there is specific topic on coastal geomorphology and application of geomorphology, right? So basically I have written only these four bullet points. We will cover each and every topic of the syllabus, but this is most important, right? So there will be some basic conceptual questions on geomorphology, right, which we have compiled. Another one are there are questions on landform created by basically five agents. One is river, landforms created by glaciers, landforms created by groundwater, landforms created by wind. We also call them aeolian landforms. And one is of course coastal landforms, right? So these files are very common. In one year UPSC will ask you about river landforms, another year glacial, then groundwater, then maybe again river, then wind, then coastal, something like this happened, right? So we'll also see previous year questions, what kinds of question UPSC is asking, right? So that is one thing. Another thing is, so these questions are fixed, right? They will ask this question or this question in compulsory in every paper, whether it is civils or forest. Then they another as in another question, sometimes they may ask you about weathering, sometimes about soil profile, sometimes about drainage pattern. All right, there is also this concept of geomorphic cycle given by Davis and Pank basically, and some other geomorphologists. But this is like pretty rarely asked. These are mostly more of concept of geography and rather than geology. In geology, they are not very much accepted views, right? But still, it is mentioned in our syllabus, so we will cover them. But these two are the most important, basically the topics which we need to cover, right? So see how we will. This is like the very basic. So how we will cover this part is basically uh, we'll cover through handwritten notes as well as I also have slides like I covered in last time, right? So these are my own handwritten notes. They are very very robust. The only problem with them is that they may not have very good handwriting, but I'll explain them in class. Then you can jot them down, right? You can jot them down and you can make your own notes. So they will give you very very good quality content, right? uh, So, all right. So now, just to begin with, now before starting, we can also do some previous year question analysis. So, like instead of doing year wise, firstly I'll show you this compilation. This is previous year questions asked in civil services, right? Civil services exam. So this is compilation till 2016, and उसकी आगे का year 17, 18, 19 I'll show individually, right? So in remote sensing, see, they are asking also very simple question. Ki what is like this was old question. What is geomorphology and its relation to structure, right? I hope this is visible. दिख रहा है ना आप लोगों को? Right. Okay. So like today one of the laptop is not working, so I am not able to read your comments there, right? So I have to again minimize this. So that is the thing. So this is basic concept in geomorphology. This is the most important question, right? So sometimes they will ask broad question, basic concept, but this was 2007. Nowadays they will not ask this broader question. They will dig into it, right? Then the second question, the most important question is on basically landforms. So see, every year they will ask some question on landform. 2015, 13, 12, 11, right? So they are either they will ask landform related to some particular agent, or what they will do, they will name that landform and then they will ask. They are asking about trellis, loess, moraine. So moraine is basically glacial landform. Loess is basically wind landform, right? Then something like this they keep asking, right? Then this on geomorphic cycle and interpretation they have not asked since from in last 2 decades. So that means it is not that important, but we'll cover it. Then this is a very common question. They have directly picked up from syllabus. Syllabus ही पूछ लिया in the form of question. Role of lithology in structure and development of landform, right? So this is there. So I think this is the most important thing. Then there of course they ask sometimes question on weathering, right? So we can directly see some of the question. So this was civil services and this is forest services. So in forest service exam, see, this is the type of question they will ask, right? Discuss landform produced by wave erosion. So basically, they are asking about coastal landforms, right? Landforms created by wave or tides, right? Something like that. Then they will ask various fluvial landforms, right? Something like this they are asking. Then they can ask again some question on landforms. Write a short note on alien landforms, right? Then like this is very common kind of questions, right? And then they ask some other questions. So like if we'll see paper wise, I'll start. This is geology paper 1. I think this is 2014 question paper. So in 2014, this is I hope you have seen the question paper, right? I hope you have seen the question paper. So this is how our question paper look like, right? This is paper 1 geology. So it will have basically uh, basically 8 question, and out of 8 question we have to attempt only 5, right? So how we have to attempt 5? Question number 1 and question number 5 are compulsory. So this question is compulsory. We have to attempt all these 5. Basically this is forest service. So these are our 8 marks. If this was civil services paper, this would have been of 10 mark, right? And then again this in section B, this is compulsory, and then we have to choose at least one more. We have to choose at least one more question, right? We have to choose at least one more question from. So maybe you can choose question number 2, question number 3, and then you have to choose one. Maybe you choose question number 7. So this is how you need to attempt the paper, right? You have done 5 question. Question number 1 and 5 is compulsory, and you have to choose at least one from each section, and in total 5, right? So this is how you do. So like suppose this is paper 1. So we have general geology, geomorphology and remote sensing, and then structural geology in section A of our syllabus. So this is how it will mix up, right? This is structural geology question, this is structural geology question, this is general geology, this is general geology. And then in geomorphology, they have skipped geomorphology, they have asked remote sensing, right? Then here also this is general geology, this is remote sensing, and this is structural geology. Then uh, here they have asked geomorphology. This is general geology, this is structural geology. And in this again in question number 4, they have again asked same one question from structural geology, one question from general geology, one question from remote sensing. So in this year in forest services, they have not asked much on geomorphology. This is the only question they have asked, and this is also very traditional question, right? Directly from the syllabus. Now similarly, this is 2016. This was one of the difficult paper, right, in 2016. So see, even if it's difficult, it is not that difficult. So again, in geomorphology, they have asked from remote sensing, right? From geomorphology remote sensing chapter, they've asked from remote sensing. This is what? This is structural geology. This is what is seismic wave, effect of seismic wave, all these things, features of seismic wave. This is general geology. Then seismic zones. This is general geology, and this is unconformity. This is also basically this is structural geology. So 2 question from each and 1 question from geomorphology remote sensing. But sometimes it is like that ki they ask 2 question from geomorphology, 1 question from general geology, and 2 from structural geology, right? And then one each in all these compulsory question. So this is geomorphology, this is structural geology, and this is various volcanic belt and product. This is general geology. So yeah, they directly ask the concept of Davis, right? So this is the last time they have asked, and then after that, it has been 8 years. They have not asked on geomorphic cycle, right? So that was it. Then again here, they have asked on GIS and GPS basically. So it is also from mm, remote sensing part. right? And what else do they ask, right? So this is which paper? I think this is 2000. This is this only this 1 month old paper. This is Indian Forest Service 21 question paper. So let's see what they have asked this in this year, right? From geomorphology. So in this question, they have not asked anything from geomorphology, right? This is plate tectonics. This is also basically this is a question from geomorphology, right? So this is one question in compulsory they have asked, and then another question what they have asked is that they have asked something on mass wasting, right? This we will also do in engineering geology. And in this fourth question, they have asked simple what is weathering and different processes of weathering. Simple, very very simple question, right? This is IS paper 2017, right? Here see what they have asked in. Uh, so they have asked about karst topography. So basically, this is landform created by groundwater. Very simple. And here in this question number 2, they are asking about some geomorphological and geological features. So basically, they are asking geomorphology of India. So that is also one of the topic of our syllabus, right? This is the topic, geomorphology of India. So with that they're directly picking it up, right? So now you understand what is the syllabus, right? Just memorize the syllabus, basic concept and weathering. Then there are something on landforms, geomorphic cycle, and then similarly basic concept of geomorphology. And there is again coastal geomorphology is like landforms of coastal areas, and then there is application part and geomorphology of Indian continent, right? So the very same thing. Like we can analyze few more paper, and then we will so this is civil services 2021 paper. So in civil services 2021 paper, they have asked from remote sensing, right? This is the question from remote sensing, that what is GIS, what is concept component function of GIS. This is part of remote sensing basically. And then again in geomorphology they have asked simple, discuss the geomorphic processes, basic geomorphic processes which we'll study, and for aggradational or degradational, that is for depositional and for erosional landforms of fluvial. So basically they are just asking fluvial landforms, that is landform created by rivers, right? Very easy. So like this is the most common question, landforms created by river, right? And then see this is a conceptual question. So what are fundamental concept, right? And explain the concept, something they have given a line, and then they want us to explain, right? So this is very easy. This was directly from my class notes, right? Handwritten notes से direct ये सवाल आया था. And this was one of the difficult questions for most of the people, right, who don't read books. But like this is something we covered extensively in class. So it is very easy, like you understand what kind of question. Mostly they are asking this kind of question. Landforms associated with some process, fluvial or wind or coastal, something like that, right? If you want, we can take few more papers, like maybe this paper. So this is 2022 IS examination. So here what they are, I think if you are paying attention, you must have seen that they are asking this meteorite question almost every year, right? In one form or the other form. This is from general geology. So we have covered it quite in detail. So from in this chapter from here, they have not asked much. They have asked this. They have asked two landforms associated with a cold, hot arid and cold arid. So basically, this is desert landform. They are asking about desert landform. Right. So again, a question on landform. Then this is difference in geomorphology of eastern coast and western coast. So this question is from geomorphology of India. And then again, this is basically they are asking about weathering, soil formation or weathering. So the soil formation is also one of our topic. You can see here this they have mentioned as weathering and soil formation, right? So like this is quite simple questions. I have shared these previous year questions also on the portal for forest services, and for civil services also I will share in this geomorphology course, right? All right, so now we'll begin with the classes. So basically we'll first do with some handwritten notes. So basically, what is geomorphology, right? What is geomorphology? So geomorphology is made up of two words. One is geo, another one is morphology, right? So geo is basically earth, right? And morphology is basically how does it looks like morphology is the shape basically. So geomorphology, so it is basically the morphology, the features, the shape of the like what are the features present on the surface of earth. So in general geology, what we did basically what is inside the earth, right? We studied about origin of earth, then we studied about what is the internal structure of earth, right? What is mechanical differentiation, mechanical differentiation. And then we studied about what is crust, what is mantle, core. And we studied about some processes happening inside the earth. We studied volcanoes, earthquakes, elastic rebound theories. We studied isostasy. We right, all these things we studied, right? So basically, and we studied about how and why mountains are formed, what is plate tectonics, what is convergent, divergent, transform boundary. All these things we studied. So this is mostly inside the earth, right? In geomorphology, our focus comes now. We have come up outside the earth. Now we will see macro features outside the earth, right? How earth looks like. If there is mountain, then where do river flows, right? Where do river end? The river flows through valleys, river end in deltas, right? How is desert? How does desert look like? How does glacial terrain look like? All these things we will study, right? So this is geomorphology. Then we will zoom into practical aspect, that is remote sensing. And then we will study more in deep. We will pick up rock and we will study igneous petrology when if the rock is igneous, right? Then we will study sedimentary petrology, metamorphic petrology, and this is how we proceed. And this is how UPSC has given us the syllabus. So basically, geomorphology is basically a science of study of landforms. Right. So forms you understand. It is again this morphology and forms. So what are the features on the land, which we call them landforms. So can somebody tell me some of the examples of landforms? Tell me five examples of landforms. What is landform? Examples of,
Mountains,
yes, mountain can be a landform. River valley,
plateau,
yes, plateau can be a
Oxbow
landform.
Lake,
Yes, Oxbow Lake you have read, right? Geography also. So river Oxbow Lake hai,
Moraine.
right? There is moraine glacial landform, right? In simplistic, one is very famous, that is delta, is a landform, right? Similarly, right? So these are
Alluvial
landforms,
fan,
alluvial fan. So these are all riverine landform. Then there are also landforms created by wind basically. In desert you'll see, you'll see lake, some kinds of lake, they are known as playa lake. In desert you'll see some kinds of dune. Similarly, there,
dunes,
yes, there is,
Buzzard,
yes, there is glacial. We live in a tropical country, so we don't have chance to look glacial landforms, right? If somebody of us visit to, higher latitude, higher altitude, like near the Himalayas, so we might see some kinds of glacier and those activity. So that is why some glacial land might not be very normal to us. Like there is moraine, right? And there are a lot of things. Similarly, there is groundwater. Just now that we had this question on karst topography. So all these are example of landforms, right? So basically, geomorphology is a science of study of landform. So we study about origin of landform, about evolution of landform, about destruction of landform, right? Like for example, one of the most common landform which everybody of us has seen is waterfall, right? So waterfall is also an example of landform. So right. So basically, so we can understand that it is about study of landform. Suppose we'll study about waterfall, how waterfall got originated. Maybe there was a maybe there was initially there was a terrain like this and the river was flowing, right? So and there was some there were rocks, rock A, rock B, rock C, rock D, right? So what happens? This is river bed. This is river bed. So river keep eroding this bed, and it is given that rock A is a hard rock, but rock B is a soft rock. Rock C is a hard rock, right? So when a rock is hard, it is difficult to erode it, right? River will find it difficult to erode. So in some time, what might happen? Something like this happen. A will remain, but B is soft. It will get eroded more, right? And something like this will be there. So basically, this is in starting of a waterfall, right? With time, there will be more differential erosion of this rock B, right? Rock B, and ultimately it will become something like this, right? River bed will become something like that. So it is basically a creation of waterfall here. So this is the domain of geomorphology. It will study the origin, it will study evolution, and maybe destruction, how it get destroys, right? Something like that it studies. So this is very basic, right? Geomorphology is science, it is more about landforms, study of origin, evolution, and destruction of landform, right? So like before going into more concepts of geomorphology, I want to get through with some basic terminologies in geomorphology, some basic terms, basic keywords, right? So like there is this term landform and landscape, right? Landscape we all study, we have heard, right, this, even if you have been to some, at some, at some vacation place, we see that the landscape is very beautiful, the scenery is good, right? Something like that. So we should know, in general normal parlance, we assume landform and landscape to be the same thing, but technically they are different, right? So that is the thing. Technically that is the thing. So like what is a landscape? Can anybody tell me what is a landscape? Just by your normal understanding, how will you define landscape? Actually, when I went to my first IFS interview, I was asked this question, right? I was asked this question about what the difference between landform and landscape, right? So this is also given in books, very basic books. So see, basically, right? So basically, suppose you have been to a location, maybe you have been to Gangotri, right? Gangotri, or maybe to Masuri, some hill station, right? So and suppose you are seeing a scenery, right? You are standing on the top of a mountain, and you have views. Just give me a minute. Maybe somewhere even in Masuri, maybe, right? So you are having a view. So what all thing will you see, right? What all thing you will see? You will see maybe a mountain is there. You will see a river is flowing, right, through its river valley. You might also see some kinds of waterfall. And you might also see some kind of glacier, right? Like from Masuri, glacier might not be visible, but maybe from Gangotri it will be visible, right? So you are seeing lots of landforms basically, right? So there is this valley, it is a landform, mountain is a landform basically in a way, right? Then there is this waterfall, glacier landforms you are seeing. So basically, landscape is landscape comprises multiple landforms. It is a broader term, right? And it is also a subjective term. Landscape is a subjective term. Landform is an objective term. It is a very specific term. If you are spacing, you are saying some landform, it is specific to a single landform, right? So basically, this is the difference. Landform is basically subset of landscape, right? So it is pretty objective.
Sir,
Yes.
sir, what is a biome?
What is a biome? The biome is a ecological term, right? We don't have to study it in geology. So biome is a ecological term basically. So it is an basically geographical area which is which has all things, which has hydrosphere, lithosphere, like water is there, soil is there, all kinds of uh, biotic masses are there, including animals, plants, like leaves, all these things. So that is a different thing. So we don't have to study that in geomorphology. It is more of ecological term, right? So we'll discuss about it later if you want, maybe just after the class. What is a biome? What is the ecosystem? Right? All these things. The difference between them. So that we don't. It is not related to this, right? Here we are studying about.
So land, when we say about landscape, so landscape can be both found in rural and urban also, na? So both of the
Yes, yes, yes. So,
both type.
so basically, see, lands. This is what I'm saying. This is a subjective term. It is difficult to define, right? So
Hmm.
it is difficult to define for you. Even there could be an urban landscape, right? This is also we write in gender studies. We also write in policy that we need to improve our urban landscape. We need to improve our basically infrastructure system. को भी वो बता देंगे. So this is what I am telling. This is a subjective term. It is difficult to define, right? But in a simplistic manner, you can say that it consists of multiple landforms in a natural setting. It consists of multiple landforms, right? So maybe you can relate this landscape to biome also in ecology. So it is a loose term, but this is a more technical term, landform, right? So landform means a specific feature basically. So that is why it is more objective to define, and that is why we say that geomorphology is a science of study of landforms and not landscape, right? So these are two very common terms. Sometimes people landform को landscape बोल देते हैं, but that is not. This is something what we should not do, right? So I hope it is cleared. Right? Nothing important exam में नहीं पूछने वाले ये, but you should know, right? Landform is the specific term, and a single landscape might have multiple landform, might not have multiple landforms, right? So another terminology which we should know. I hope it is clear. Any
Yes,
doubt?
sir.
Okay. So okay. Now another important term is geomorphic agent. See, I have slides also. This might not look very neat to you, but these were my short notes kind of thing. So these are ultimately this is what which will help you, right? I'll definitely share the slide with you, Abhi. But yeah, so geomorphic agent is a very important term. These are those agents which drives the forces of changes in landform, right? Suppose we have a landform. I said that we had landform. We have waterfall. So initially it was a flat terrain, right? And with what this there are the vertically different rocks was there inside the earth, and this was a soft rock, and somehow some kind of this waterfall developed, and with time this waterfall got even steeper and it became a real waterfall. Something like this happened. So there are certain agents, certain forces which is changing this landform. Even if you have river valley, we'll study about it, that initially a river valley, like suppose we have river Ganga, right? So where from where does river Ganga start? It starts from Gangotri, right? There are two very important tributaries. One is Alaknanda, another one is Bhagirathi. So basically, from there they start. So if you'll see Alaknanda, Bhagirathi, and even everything which is above Haridwar or Rishikesh, that is the Himalayas region, you will see that the slope of the river Ganges is very steep, right? But when the river Ganges comes down towards below Haridwar and Rishikesh, it enters the field. Its slope decreases. Basically, it becomes more flatter, but it becomes wider, right? In Kanpur, in Varanasi, Allahabad, at all these places, it is very wide, but it is not very steep. It is very deep, but the gradient is not very steep, right? So basically, this is also evolution. Of course, these places are different, but this is how uh, it evolves, right? So and actually, if you'll go few million year from today, maybe even the slopes of Himalaya region, they will become very gentle because of the erosion. So here the forces of erosion are operating, right? So these are geomorphic agents are those basically those forces itself, right? So basically there are two kinds of geomorphic agents. One is exogenic, another one is endogenic, or they are also written as exogenetic. Another one is endogenetic, right? So like what is endogenetic, and like suppose this is surface of this is earth, right? And this is all, this is our atmosphere basically. So endogenetic, endo means inner, exo means outer, right? So genetic means genesis, genetic means from where it has originated. So endogenetic agents or endogenetic forces or endogenetic processes, all these terms can be used, right? So this endogenetic, I'll use endogenetic processes, right? So endogenetic, these processes, they originate inside the earth, right? They originated inside the earth. So what are the processes, what are the forces which originate inside the earth? We have read them in general geology also, some of them. One is volcanic, right? Volcanic processes, earthquake, tectonic. Basically, we read about elastic rebound theory. So it is about stresses inside the earth which leads to rupturing of rock and movement of rock, leading to earthquake, right? Generation of seismic waves. So these are, there is also folding, faulting, right? So all these things we will study in structural geology, right? In very very detail. So I hope you understand what is folding. If you don't, don't worry. Like folding is basically, suppose these are layers of rocks and somehow they are under stress, right? So what might happen, they might break or they might buckle, right? They might fold basically. So they might under the stress of, under the effect of these forces, they might bend basically, something like this, right? So this is known as folding, basically folding. So all these things, all those processes which leads to folding, faulting, which leads to volcanic activities, earthquake, these are endogenetic forces, right? What are exogenetic forces? So generally these endogenetic forces happens in, they operate inside the surface of earth, right? They can obviously, they can obviously express themselves above the surface of earth, just like volcano happened. Earthquake also has this manifestation on the surface of earth, but they are inherently internal forces, right? Forces which are operating inside the earth. What are exogenetic forces? Logically, then these are the forces which operate at or above the surface of earth. Basically, these are the forces which operate in the atmosphere. The surface of earth is also atmosphere basically, right? These are exogenetic forces. Okay, anybody tell me what are the some example of exogenetic forces or processes which happens on the surface of earth and which affects landforms? Suppose this is surface of earth, this is a mountain.
Wind, river.
Yes, very good. Surface of earth, suppose this is mountain, right? And maybe I don't know why this red color is not working, right? So suppose this is a mountain, river is flowing from them. So what does river do to a mountain? It erodes them, right? It weathers them. I hope you understand what is weathering. Weathering is a specific topic in our syllabus, and I will devote a dedicated lecture to that, right? Because there is always a short note on it, and I have very good prepared notes for it. But I think from just your basic understanding, you must be knowing what is weathering, right? So weathering is a process of breaking of rocks, right? There is a rock there, right? So weathering is a process through which they disintegrate. It is a process of disintegration. Got it? And then there is another process which you must have heard somewhere, is erosion. ना अखबार में भी पढ़ते रहते हैं ना, there is erosion of some beach is happening, erosion of river bank is happening, right? So you know what is river bank? This is suppose here river is flowing, right? So you understand what is river, right? River bank. River bank is this, the side wall, this side wall. This is river bank. These are very basic things which we should know. And the surface from which river flow, we call it river bed. So like these are all technical jargon in geology. You should, and like everybody knows it, but you should use it more consciously, right? River bed is a is a geological term basically. River bank, the sides of the river, we call them river bank. So we say na the city of Muzaffarpur, the city of Kanpur is situated on the left bank or the right bank of river Ganga, something like that. We say that, right? So what I was saying, suppose this is a mountain, this is a lake, right? This is a lake. So what is happening? This is surface of earth, river is flowing. So this river is weathering rocks of this mountain, right? It is basically disintegrating them, and it is eroding them. Like weathering is basically disintegration, erosion is basically taking away that broken rock, right? So it is basically transportation of the material. So this is happening. So this river is doing this. The same thing is also being done by wind, right? Wind is also a very important and a powerful eroding agent, right? In desert, wind carry the small sand particles to thousands of kilometers. You must be aware of that, right? The same thing is even done by glacier. Glacier is like a tortoise, it, right? So like what is tortoise? Tortoise walk very slowly. So that is what glaciers are also doing, right? We might see that glacier is static, we see that wind is blowing, river is also flowing, right? Because we can see it. So in geological time scale, glacier also moves. Glacier is basically river of ice which is moving, but they move very slowly. They might move just 1 millimeter in 1 year, or 5 or 10 millimeters per year, but they are also moving under the effect of gravity, but it is not visible. But ultimately they also move in few million year time, they will move kilometers, right? So same is the case. Then so such things are also being done by sea water, right? Through waves and tides. So basically here they erode, and when they get low gradient, they deposit here. So here we are getting deposition. So these changes done by glacier, right? So these are all example of exogenetic agents. And what are the process through which these exogenetic agents operate? It is weathering, erosion, right? All these things. And we will read just after few minutes that these weathering, erosion, or these rated deposition, these terms, it is like these are terms which even a layman can use, right? But as a geology student, we will use some better terms like degradation, aggradation, right? So we'll see them. So I hope you got basic idea about what is endogenetic or exogenetic forces, right? We will. Okay, there is some question. Yes, Shiv, you want to ask something?
So gravity is a endogenic component or exogenic component?
Actually, gravity is both, right? Gravity operates everywhere. Gravity also operates inside, it also operates outside, right? It is the center of mass, we say, which is basically pulling. So gravity, but what we see normally is that gravity is actually a facilitating factors in all these agents, right? Even for this river, suppose this is mountain, which is these are broken rocks, weathered by this flowing river. So of course river is flowing, but even the gravity is helping it, right? Gravity is helping it. Same is thing, the gravity also helps glacier, it also helps. So we cannot actually classify gravity as endogenetic or exogenetic, right? But generally you will see that most manifestation of gravity are exogenetic only, right? Endogenetic,
Okay, sir.
right? Endogenetic, if you have to classify, you have to write, you can write gravity along with water, air, glacier, you can write gravity also, it is correct, right? In most book also it is written in that way. Endogenetic are generally big forces, right? Tectonic forces, volcanoes, earthquake, faulting, right? So these are more related to tectonic activities, right? So in endogenetic, so you can slot it here if you have to, right? So that is it. So basically now the second term we use, first was landscape landform, second was endogenetic exogenetic processes, right? So basically this water, wind, glacier, these are exogenetic. Endogenetic, what I said folding, faulting, volcanoes, right? These are endogenetic, right? Then there are all those forces which you read in the last class taught by Lawrence sir, right? All epirogenetic forces, right? Whatever which led to this mountain building, all those forces which led to mountain building, which led to continent building, right? These are the endogenetic forces. So if it is good, you can write these name or you can use these terminologies, right? So believe me, we check a lot of copies in our test series. So people, it is good to simplify stuff. But now we have given you one full-fledged lecture on epirogeny, right? Believe me, 99% of geology students, even they don't know, they will struggle writing something on epirogeny, right? So you at least use the term, right? We have epirogeny, all the epirogenetic forces, all the orogenetic forces, they are all example of endogenetic, like endogenetic forces basically. So this is keyword, right? And this third thing, before going to the slides, the third thing I want to discuss is this gradation, right? So this gradation is basically a process, right? It is a process which leads to change in elevation, right? This is a process which leads to change in elevation from higher, elevation of land basically, to higher to lower or from lower to higher, right? To a common point basically. So what is gradation? Gradation is a process of change in elevation of land from higher or lower elevation to a common level, or generally we use the term base level. like like you all are sitting in this class and you have a motto in life, and your motto is in life, there might be a lot of mottos. One of the mission is to clear civil services exam and to become IAS, or maybe to become an Indian Forest Service officer, right? Or maybe an IPS officer. So this is your motto in life, right? There are rivers worldwide. There is river Ganges, Brahmaputra, Nile, Amazon, right? There are a lot of rivers. They also flow. Then they flow under the force of gravity basically, but they also have a motto in life. And you know what is their motto in life? Is to erode everything to base level. And what is base level? What is a base level? Can anybody guess?
Sea level.
Yes, generally this base level, like if we correlate this globally, it is base level, or it could be even a lake. Like suppose a river is flowing, and it don't, most of the rivers they ended up in ocean, so we, or they ended up in sea, so we call them sea level. But there are certain rivers which may end it in a lake. So for them, suppose river is just standing here and this is a lake, so for them this lake, right, the surface of lake is the base level, right? So that is like there are a lot of river which basically flow in this Sambar Lake, right, in Rajasthan. So for them, the base level is that lake. But yes, you are right. Generally, globally, the base level is sea only, right? So ultimately, what they want is they want to erode the land to sea level, and then they will stop flowing, right? So just all right. So now, so basically, degradation, the process of gradation is of two types. One is this, we call it aggradation, and another one is degradation. This is degradation. I hope it is visible to you. And this is aggradation. So like suppose again this is a mountain and a river is flowing through it, right? River is eroding this mountain. So this process of erosion basically, or this process of decrease in it's the height of the mountain. This process trying to erode they are to bound level to the base level is degradation process, or right. And what is aggradation? Is a process which try to fill up this basin, right? Suppose this is a basin which is below the level of sea. This is nothing, right? This is nothing. This is below the level of sea, and suppose this is a sea level. So this river will try to fill this up to this level, right? So the aim of the river is to erode the mountain and to fill the basin basically. It want to level everything up, right? So you can say river, or river has a mode of equality, right? It is flowing with the aim of making everything same, right? Something like that. So basically these are the process trying to bring, read this, these are the process trying to bring the surface from higher to lower level to a common level, right? From a higher level to lower level to a common level. So we call them gradation. They are of aggradation or degradation. So basically Degradation is more like what? Weathering and erosion, right? And aggradation is what? Aggradation is more like, in common term, it is deposition. So just use this terminology liberally, right? Now just I'll go through the slides and then we will come to the most important topic of geomorphology. That is the basic concept. So basically, again, this is the formal slides. So what is geomorphology? It is branch of geology that studies basically landform. What features of landform? Origin, evolution, destruction, or here you have written that studies the characteristics, configuration, evolution of landform, if you want to use good English, right? So this, like, these are all example of landform, right? We will study each of them. So basically this is a desert, this is all desert, you can see this is all desert, and this is a landform which we call as, you must have read in general studies, mushroom rocks. This is a glacial landform, right? This is known as moraine, right? This is medial moraine, this is, side moraine, there's terminal moraine, all these things, right? This is also a landform created by river in its mature stage, right? We will study all this in quite detail. This is we call this is basically meanders. So right, okay. Now just tell me, why surface of earth is uneven, right? Just we are revising whatever we have done. Why is the surface of earth uneven, right? So like one of the reasons for this unevenness, and one of the concepts which explain this unevenness of elevation of various features of earth is isostasy, right? But and we read isostasy, right, in basically uh, in general geology, right? But isostasy is more related to the roots of the various landforms, mountains, and all these things, and right, it is more related to internal processes, right, which is operating here. Why there is unevenness of surface is because of simple, because of interplay between endogenetic and exogenetic processes. I forgot to tell you one thing, that mm, generally endogenetic processes, what they do, they increase the elevation generally, and exogenetic processes generally decrease the elevation, right? Like for example, endogenetic processes are example of endogenetic processes: volcanism, right? Earthquakes, and like basically right, there is folding. So folding also appears to increase the elevation, right? Volcanoes also, basically this is surface of earth, there is some volcano brewing up, right? Whenever it rises, what will happen? Whenever it rises, what will happen when it comes to the surface of earth? It leads to basically some kind of warping, dome like structure happened, right, because of volcanoes. So all these processes generally increase the elevation of earth. But this is, I am using the term generally, this is not the case. Like for example, you know that volcanoes generally we have read various kinds of volcanoes: stratovolcano, cinder volcano, right, shield volcano. They all have an elevated structure. But then there were some volcanic landforms which were depressed also, right? We read about two things: positive landform and negative landforms, right, of volcano. So there was some negative landform. Can somebody tell me an example of negative landform where the elevation decreased basically?
Crater.
Yes, crater, or the crater ko hum log we also use the word caldera, right? Crater lake, right? So how was it, produced? It was produced, like suppose this is volcano, this is volcanism, right? So this is volcanism, and volcano is coming up. So how is crater formed? We read it, right? So basically this, when this volcano comes, it comes with so much power that it will actually blast all these rocks. It will in a way blast out this mountain itself, right? So जब ये फटेगा, उसके बाद in this area a depression is formed, we call that caldera because of the explosiveness of the mountain, right? Plus explosiveness of volcano, basically. So basically, this if you are asked that why is the surface of the earth is uneven, surface of earth is uneven, it is because of interplay between exogenetic and endogenetic forces. Generally, endogenetic forces want to increase the elevation, exogenetics want to suppress the elevation. So whenever it is about them. When if at a time endogenetic forces will dominate, we will have elevated structures. Then exogenetic forces will keep bringing them, like weathering and erosion. Through weathering and erosion, they will keep bringing down the landform to a base level, right? Then maybe some tectonic activity might happen, maybe uplift happens, right? Maybe some subsidence might happen, so it will again change the elevation. Then again exogenetic forces will try to bridge it, right? Similarly, generally these exogenetic forces decrease the elevation, but they can also increase the elevation, because we will study that there are two kinds of landforms. One is depositional, one is erosional. So in depositional landform, we do get elevated landforms, right? Suppose there is a basin and a river is bringing a lot of sediments to it, right? So initially, the base of this basin is how much? Maybe 100 minus 100 meter. This is sea level. So इससे भी 100 मीटर नीचे है, right? But with time, this river will keep bringing sediments here, and maybe after some time its elevation become minus 20 meters. So basically here exogenetic process is increasing the elevation, right? But that is why I use this term terminology. So why is the surface of earth uneven? It is because of interplay between external forces, which is exogenic or exogenetic, or internal forces, that is endogenetic, right? These exogenetic forces result in degradation of elevation and aggradation of basin, right? So basically, if there is elevated area, it will degrade it. If there is basin, it will lead to aggradation, right? So these opposing actions of exogenetic and exogenetic forces result in variation in surface relief. So this is the answer, right? Then what is geomorphic processes? There are two kinds of geomorphic processes. They are endogenetic and exogenetic forces, right? Geomorphic processes are those processes which leads to change in elevation of basically landforms. So they can be endogenetic or exogenic. So you can use both the spelling. Genetic भी use कर सकते हो, GENETIC, और genic भी use कर सकते हो, which is written in this slide, right? Basically. So what are the example of endogenetic forces? We just discussed folding and faulting, volcanism, diastrophism, earthquake. Basically, all these are example, right? So if you have to use these terms in exam: faulting, volcanism, earthquake, and diastrophism, right? So like what is diastrophism? Diastrophism is nothing but it is another term for tectonism, right? So basically, all these, whatever is written here, 1, 2, these 3, these are all subset of diastrophism. You can basically, diastrophism is a daddy term, and all these volcanism, earthquake, these are its child, right? So what is something like this? So it is basically diastrophism. All those most of the processes for forces which we study in general geology, they are more or less example of diastrophism, right? You can also read this in like formal definition if you want. Actually, this is also given in NCERT, right? So diastrophism is also called as tectonism. So it is large scale deformation of earth crust by natural processes like the same processes which formed oceans and continent, which mountain system, rift valleys, right? Everything, volcanic folding, faulting, all these things, they are all under diastrophism. Got it? So use this term. What are exogenetic processes? Weathering, mass wasting, like weathering हो गया, erosion, transportation, deposition, ये तो हम साथ में use करते हैं, all these terms, right? Weathering कई subset is what? Basically disintegration, right? उसके बाद there comes the process of erosion. So erosion includes what? Transportation and deposition, basically. So they are using more and more terms, right? They are all more or less related terms, and when they have used mass wasting. So mass wasting is nothing. What is mass wasting? In simple language, what is mass wasting? It is landslide. Actually, this is also a very common question. Just like UPSC keep asking about what is meteorite, they keep asking what is mass wasting, right? They don't have any other questions. They keep asking mass wasting every year. So landslide is basically a type of mass wasting, right? The land can slide in a slow way, in a very fast manner, right? There is avalanche in glacier, there is landslide in mountain areas, right? There could be mud flow, there could be a lot of other kinds of landslide related terms. So they are all part of mass wasting, right? So that is it. So what is a geomorphic agent? An agent is a mobile medium which removes, right, which removes, then it transports, and somewhere it deposits earth material. For example, running water, that is river, or groundwater, right? Groundwater is also running actually, but it flows at a slower rate. Then moving ice, that is glacier, wind, waves, currents, all these are agents of geomorphic agents, right? So now we'll go in more detail of some of this detail of endogenetic processes. So it is very easy. You should just know the example basically: faulting, earthquake, volcanism, diastrophism, right? And basically these are the forces caused from within the earth, right? And what is the energy sources of endogenetic forces? So all those forces which led to mental currents and plate tectonics, right? So what are the reason of mental current is basically partial melting, right? So why partial melting happens? Because of radioactive heat generated by K40, right, which is abundant in Earth's crust. Then due to primordial heat, when Earth was generated, it was very hot. So a lot of that heat is still stored inside the Earth, right? And then due to gravitational accretion also heat is generated, all these things basically. So nothing that important. And then see, these are they are going in detail. Suppose if you got a question on 10 mark and write a short note on endogenetic process, so you know the heading, you can write something about volcanism, something on faulting we will study in great detail in structural geology. Earthquake you already know, so maybe in earthquake you can talk about elastic rebound theory, something like that, right? But generally it is not asked. So these are some fold right, types. There are three kinds of fault. One is normal fault, reverse fault, another one is strike slip fault. So these are all we'll do it in folding faulting, so do not worry about it. And just definition, all this thing, so you go through it later when we are done structured geology, right? So this is all folding and folding, don't worry about it. This is very basic thing, it will get covered subsequently, right? Then these are fold types of fold, right? We'll do it. Then volcanism also, what is process. Volcano is what? Volcanism is a phenomenon of eruption of magma on the surface of earth basically, right? So eruption of volcanoes or magma is the main source of igneous rocks, all these things. So basically then earthquake is there. Earthquake is nothing but sudden shaking of the surface of earth, right? Due to passage of seismic waves, something like that. So all these things. Then there is also some content on diastrophism. So you see, it is basically the same thing. It is basically tectonism, right? All these things. Now again, I think I have covered this one. Can you tell me, this is also another question which is commonly asked in interviews. So what is difference between erosion and weathering? Abhi isko we have covered it. Can anybody tell me difference between erosion and weathering? I have explained it already. Anybody? Marine, Kaushal, Vivek?
So erosion includes transportation and deposition.
Yes. Basically, weathering is
Weathering is breaking up of rocks or
yes. So basically, there is a rock, and it is in situ. You understand what is in situ? At the site. It is a process which happens at the site. जैसे यहाँ पे breaking up हो गई है. Then some agent will come up and it will transport it and deposit it somewhere. So basically, erosion has an element of transportation, right? So basically, erosion is ex situ. It is something.
And sir, erosion is also associated with displacement,
Yes.
and weathering is associated with disintegration.
Yes, very good. Right. So instead of displacement, better word to use is transportation. Right. Transportation of sediments. It transport the sediment, or maybe it displaces the sediment from one place to another. So very good. Right. That is what it is. So it is a disintegration of rock. Disintegration might be due to physical process. It might be due to some chemical disintegration. right? So weathering is a process of decomposing or disintegration of rocks. It might lead to change of rocks, right? All these things. So once these small pieces of rocks are changed or they are broken apart by weathering, they may start to move by wind, water, or ice, right? And this process of movement is known as movement, as well as deposition is known as erosion. So basically, in erosion, there is an element of transportation, or as Marine said, element of displacement, right? And another thing is erosion. Erosion is XC2. It approach it links it basically operates at a different site, right? And this weathering is in C2, right? In C2, that is at the site, that is not at the site, away from the site, right? So these are just two things, basic things you should know. Now we come to exogenetic processes, right? So the example of exogenetic processes is weathering, erosion, transportation, deposition, right? So we'll do all these things in sedimentary also, right? So these are the base of sedimentary rocks, how rocks are formed, right? So basically all the sediments get weathered, then they are transported, right? And they are deposition, right? Or this is all erosion. And when they are deposited at a place, they get compacted, they get cemented, and they become sedimentary rocks, right? So this we'll do there also. And in weathering, this is directly part of our syllabus of geomorphology. We'll have a dedicated lecture to it, right? We will have a dedicated lecture, maybe the next lecture, next lecture will cover weathering. So here there is no transportation or no entrainment. This means the same, right? So I'm not going in detail of it presently. I'm just giving you a view. So basically, in this slide, it is covering types of weathering. So physical weathering. So you should know that weathering is of two types. One is physical weathering, another one is chemical weathering. So physical weathering is rocks are broken into smaller fragments through some physical processes. Like there is no change in chemical composition or mineralogical composition, right? In chemical weathering, there is some chemical processes involved, right? For example, this is a rock. This is the very famous limestone. And suppose there is rainfall is there, and in the atmosphere there is too much carbon dioxide. So basically water is coming and it is mixing up with carbon dioxide. So basically it is forming carbonic acid. So when this water, which is rich in carbonic acid, reacts with limestone, what is limestone? Calcium carbonate. What happens? It dissolves calcium carbonate. So there is some kind of chemical reaction happening. We can call it is chemical weathering, right? It will dissolve this and it will take it somewhere else, and there it will get precipitated and it will deposit, basically. So this is also an example of chemical weathering. We'll do it in quite detail, right? Do not worry about it. So these are types of physical weathering. This is frost weathering, right? So weathering could happen because of water and ice, right? There is insolation because of heat of the sun, right? Exfoliation. Then there are a lot of examples. In chemical, like there is hydration. Roots can also lead to breaking of rocks, right? Roots of plants, all this thing. So we'll see. Then these are example of biological weathering. In some book you will see that weathering is of three types: physical, chemical, and biological. Biological is the weathering done by humans, weathering done by animal, plants, right? So these are example. Burrows created by maybe rats and other insects, it is also an example of weathering of rock, right? So we'll cover it, right, in full detail. Do not worry. So I'm skipping it for now. You should know. So this is just one type of exogenetic process. You should not keep. You should keep your focus here. Then the second type of exogenetic process is, right. So I'll go through my notes. So I think weathering. Okay, so we'll cover weathering. So now we still have some time. We'll take 15-20 minutes, and we'll start off with. So like these are the notes of weathering. I'll cover it in detail, but for now you understand. You understand what is weathering. It is an in situ process of breaking down of rock material, right? And ex situ is erosion. So So here transportation is also there, deposition is also there, right? Like last year in some exam, geological exam, they asked a short note on write something on human something human side of weathering, right? Write a short note on human side of weathering. So it is very, it is very non-conventional question, because weathering is a very technical term, and they are asking about some human aspect basically. So basically, what they wanted to ask in this question was they wanted to ask about soil, right? In our syllabus also, you will see this, there is a soil profile. There is a topic named as soil formation, right? Weathering and soil formation or soil profile also. So actually, weathering of rocks ultimately leads to formation of soil, right? Weathering होता है तो ही soil बनता है. So that is what, and what is the significance, human significance of that is, significance to human is that basically weathering से determine होगा what kind of rock, what will be the texture of rock, what will be the composition of rock, right? कितना size रहेगा, वो nutrient content क्या रहेगा. So all these things determine the property of soil, right? If there is certain kind certain size of soil, it will have more water retention capacity, right? Something like that. So all these things, they determine the fertility of soil, and that determines the type of agriculture in the country. So that affects the human that is direct significance to human, right? That is one of the ways. Another is mining, and all these things is also linked with it, right? So basically, so there are two kinds of weathering. Sometimes you can say there is three. Another one is biological, but generally biological is included in physical weathering, right? You can use both the classification. I use this physical and chemical, right? So physical is basically disintegration, chemical is decomposition. It is also known as that way, right? So that is the thing. So I'm not going in detail. This is another thing I want to share, that this is a diagram which you will not find in any geology textbook. It is generally given in some other, maybe geography and some other textbook. So it is a very good. Whenever you have to write something on weathering anywhere in general studies, even in geology, you can draw this diagram, right? So like this is a fact that disintegration. What is disintegration? Yeah, disintegration means physical weathering basically, right? So physical weathering. So physical weathering. It actually, this is a fact. You can just remember it, that it dominates in cold and dry climate. Well, the cold is associated with what? Temperature, right? And dry and wet is related to rainfall. So if the rainfall is low and temperature is cold, right? Temperature is also low, rainfall is also low. At that places, physical weathering dominates, right? And chemical weathering dominates where there is water and there is heat, right? Because water and temperature, they are basically catalyst in chemical reaction. So whenever you will get uh, hot and wet climate, chemical weathering will dominate, right? So basically, this is in a way also related to latitudes, right? Just see here. This is a diagram, right? Here in this we have precipitation, that is rainfall, and this is temperature, average temperature, right? So as we go this side, precipitation increases. As we go here, heat increases, temperature is increasing, right? So what this means is that wherever you will have higher rainfall and higher temperature, you will have strong chemical weathering. So what are the areas in the world which have higher rainfall and higher temperature also simultaneously? What are the areas? What are the geographical regions which have high?
Equator.
Yes, equator. Very good, Kaushal. Right. So equator areas basically, so they have strong chemical weathering. Right. So you can draw this in this diagram also. So at the equator areas, you will have more chemical weathering. At ऐसा नहीं बोल रहा है कि there will not be any physical weathering, but chemical weathering dominates, right? And in the areas which have relatively lower precipitation and lower temperature, what are these areas? These are low temperature means cold areas, but they also have low precipitation. So these are basically cold desert, right? These are subpolar areas. In polar areas, there is a lot of rainfall in the form of snowfall. So subpolar areas basically, right? So you don't have to go in detail, but इसको इतना सा याद करके रखो. Just draw these 4 boxes, right? This is a very simplistic diagram. So basically you just draw something like this. So this is what, here physical weathering dominates, here chemical weathering dominates, here there is moderate chemical weathering, here there is moderate physical weathering. Simple, right? इतना इतना सा diagram बना ही सकते हो. Moderate physical weathering, here moderate chemical, intense chemical weathering, right? If possible you can remember this, but even if you don't remember these numbers, it's all right. Right? Why there is limited weathering here? Can anybody tell me in this area why there is limited weathering or no weathering? Anyone? Pranati, Pushpa, anyone?
Lack of moisture.
Yes, because at these places temperature is very low, so everything is frozen, right? And there is no water basically, and there is also lack of water is also there. Temperatures are also very cold, so there is no agent. There is no major agent of weathering, right? Glacier do weathering, but they are very slow. They are very slow at weathering, right? Even wind does a lot of weathering, but they are relatively slow. Water is the most dominant weathering agent. So there is no water, everything is frozen. That is why there is no weathering here, right? So I think this is basic. We'll study weathering in detail in one of the lectures because it is directly part of our syllabus. Now I'll just take few more minutes and we'll cover something very interesting, very important, right? This is some basic principles and some basic observations, right, in geomorphology. So there is topic this basic concept in geomorphology, and then there's some other related concepts. So that is what I want to do. So be very careful, very tentative here. And if you get any doubt, please ask me, right? So what I'm saying is some basic principles and observations which are extensively used in geomorphology, right? So like these are some basic principles. This I've written catastrophism, uniformitarianism, and something like that, right? So okay, so like see early see the most important aspect, most important concept, scientific concept in geomorphology comes with the advent of a concept which is known as uniformitarianism, right? So like before uniformitarianism, uh, you like tell me how does science develop? How has science developed? Any science, geology is also a science, right? How does science develop? Science actually developed just 500 years ago, right? So now presently some of you are civil engineers, some of you are chemical engineers, some of you are arts graduates, some of you are geologists. So we have, in modern world we have certain specification, na? We have specialization. But in earlier times, like maybe 2000 years from today, maybe 300 BC, we didn't have such specification. All the intellectual people, they were everything, right? For example, there is a very famous guy, Leonardo da Vinci. You might also have seen the movie, right? So if you will study about Leonardo da Vinci, you will realize that he was everything. Like he used to do, he was also a scientist. He was also a he was also a painter. He was also a paleontologist. He has his theory on paleontology also, geomorphology also. So at that time, everybody was a philosopher, and like everybody was a thinker. So they used to think on all aspects. They used to think on social aspect, that is human sciences. They used to think on scientific aspects, right? So we didn't have much technology, right? We don't have much idea about Earth, right? Something like that. So like even in 300 BC, you must have heard about people like, there were great philosophers like Socrates, like there was Aristotle, all these things. So they all have some views on geomorphology. So we are studying about some basic concept of geomorphology, how this geomorphology evolved into the present form, what were the thought process. So see, 2000 years from today, they didn't know much about it, right? Everything was more or less speculative, right? Somebody was saying that Earth is flat, right? They even didn't know that Earth was round. For us, it is very easy because we have satellite, we have advanced technology, we have basically spacecrafts, all these things. But at that time, it was not that, right? Even traveling was not that much possible. The ship were not built. You cannot travel long distances. Even the continent of America, they were not discovered, right? So the world was still was in dearth of information. So all these things were there, but so they had their own thoughts on own thoughts on landforms, right? So everybody was curious, uh, just like you. Whenever when you were a child and you went to a waterfall, you must have thought, right, sometime कि ये बना कैसे है, right? how has it how has this formed, right? How has this waterfall formed? Or when you will see, you will sit across a river and you will all these things will come to your mind because of curiosity. So even all those all those philosophers used to think that how and why a river flows, right? And why do they form mountains, all these things. So they have their own view on that, right? So forget 2000 year from today, even 1400 to maybe 1200 to 1600 AD. So like what was happening in Europe? Like approximate this time was you must have heard in world history. What was this time? This was this was known as Dark Ages, right? Quote unquote Dark Ages, right? Dark Ages in Europe basically. So why it was known as Dark Ages? Anyone?
Lack of knowledge.
Lack of scientific knowledge, right? And there is another way, but because this was a time when basically religion dominated. Religion had a view on everything, right? Actually church dominated. Since we are talking about Europe, that is why I am using this term. It was morely church dominated. Church dominated the politics. Church dominated the scientific aspect and everything, right? Curriculum and textbook. So church said that earth is flat, and a guy, Galileo and some other guy, they said that no, Earth is not flat; they are round. So they were persecuted because of that. They were put to jail, right? That is why we call Dark Ages. So everything was, everything. Church or the religion has some kind of view on almost everything, including landform. So that is a thing, right? So but then what happened? And another thing, what was the explanation at that time? We call the theory of catastrophism prevailed. So this theory of catastrophism is a scientific theory basically, right? This was proposed by scientists, but these all scientists were actually in a way influenced by church, right? So like what was how was the earth formed as per church at that time? It was formed by an act of God. And how does God create it? God created in an instant, like in a catastrophic event, right? So basically these mountains, these waterfall, river, deltas, dunes, all these are created in an instant, in a catastrophic event. Just like something we call Big Bang, right? So this is that even the mountain and everything is created in that way. So there was this theory of catastrophism. It was prevailing in geomorphology, right? So this is their explanation to how landforms were formed. That's it. And so this was there. So then this was taken forward in the scientific domain by various authors. Like there was one very famous author, Herald Jeffrey. He was a very prominent and a dominating geomorphologist, right? So they were of the view that everything has arisen due to a catastrophic event, right? But then something happened in something around 1600 or 17th century. Maybe there comes a guy, very famous guy who is known as James Hutton, right? There comes a guy known as James Hutton, and he proposed a theory which now we call as uniformitarianism, right? So like in a very simple language, this uniformitarianism is nothing but it is present is the key to the past. So what does this means? Like this is what James Hutton said, right? So Hutton said that all the processes, all the forces which are operating in the present moment on the surface of Earth, right? They were also there in the past, right? So like what he said that suppose today rivers are flowing. There are rivers like Ganga, Brahmaputra, right? There is Amazon, there is Nile, there is there is a lot of rivers across the world. So he said that today all these rivers are flowing. There is no reason to believe that that was not the case in geological past, right? Even in geological past, like presently we are in Cenozoic time period, right? We are in right. That is why I said you should study geological time scale. So there was earlier time, there was Mesozoic, there was Paleozoic, there was Precambrian. So he said that in all that time there is no reason to believe that these rivers were not flowing there, right? Today there are mountains and there are new mountains being built up, right? The Himalayas are still rising because of plate tectonics, because of continental conversion. The same is happening with Rockies, the same is happening with the Alps, right? So there are present mountains and a lot of processes are happening there. So he said that mountain building was also there in geological past. Like there was no reason to believe that all these mountains were not present in the past. So he said that whatever is happening in the present, it is a key, it is a window for us to see what was there in past also. Right? This was known as the theory of uniformitarianism. Right? And it also says that whatever is being formed, it has been formed through gradual, slow processes. Like it is not catastrophic. It is not nothing is created all of a sudden. Most of the things they have happened through gradual processes, right? This was his theory, right? So like I give an example of river. River flows, so there is no reason to believe that the the river didn't flow in the geological past. There are mountains today, there is no reason to believe that there was no mountain in the past, right? Today there are glacial activities happening, right? So where are glacier activities happening? Where are glacier found presently? So he said that there is no reason to believe that these glacial activities were not happening in the past, right? So all was his theory. Then what happened was there was two other scientists. One name was Charles Lyell. Charles Lyell. So see, you should remember these names. If you write these names in uniformitarianism, you will get 2 marks extra than other people. Right? Most people will score 5 out of 10. You have a chance to score 9 out of 10. Right? And there was another guy known as Playfair. So basically, these two guys they agreed with James Hutton, but basically they added something. Basically, they modified his theory of uniformitarianism. Right? So what they say that yes, present is key to the past. Whatever processes which are happening on the surface of Earth today, they happened in the past also. Most of them, right? But not with same intensity. But not with same intensity, right? For example, they say that yes, okay. He said that okay. So glaciers are operating today. So where glaciers are operating? Can anybody tell me? कहाँ ग्लेशियर मिलते हैं? Where do we find glaciers?
Height.
Yes, they are found at high latitude and high altitude, high elevation areas, right? Maybe above 4,500 meter, we may find some glacier, right? And at higher latitude, at latitude of maybe 65 to 72, no, up to 90 degrees north and south. So here we find glacier. So these two guys, Charles Lyell and Playfair, they suggested that ki, although glacier activity which are happening at the present also, they happened in the past also, but not with the same intensity, right? For example, in carboniferous times, And even in Pleistocene time, you all must have heard about Pleistocene. You all must have heard about Pleistocene time period, right? So you know that there was ice age just 12,000 years from today. There was ice age. It ended around 12,000 years from today, right? So what was happening in ice age? Today glacier is only at this part and maybe at some elevated part of the earth. But in ice ages, these are mountain peaks. And here also we have glacier, Antarctica and Arctica. But in glacial ages, in this Carboniferous and in Pleistocene time, the glacial activity was up to 40 degrees, right? All these areas were glaciated. So basically, the intensity of glacial activity was huge in these two time periods, right? So whatever is happening today happened in the past, right? But the intensity has been different, right? For example, another example I can give you is, yes, today we have mountains and mountains are getting built up, right? But there in geological past, like maybe say 70 years ago the mountain building was not as intense as it was today, right? So they said that there has been certain phases in geological time where mountain building processes they were more intense, right? So like you have done your epirogeny and orogeny classes. So I hope there you must have heard a lot of terminologies there, right? So basically, in a simplistic manner, there are more than four, but in a simplistic manner, this you should write in your notes also, right? So there are four major phases of mountain building in geological history, right? First is Precambrian. Precambrian mountain building, right? So can anybody tell me some of the example of Precambrian mountain? Anybody aware that some mountain whose age is as old as Precambrian? Anybody? Like do you know which are the oldest mountain of India? Can any? I hope you are aware about the mountains of India, right?
Ravli.
Yes, Aravali. So we have what? We have Western Ghats, we have Eastern Ghats, we have Aravalis, we have Vindhyas, we have Satpuras, right? And then we have the mighty Himalayas, right? I hope you are aware of these are the mountains of India and major mountains. These are Himalayas. This is Aravali. This is Vindhya. This is Satpura. I hope it is visible. I have made a very small diagram. Right? These are what are these? These are Western Ghats. These are Eastern Ghats. So the two of the most oldest mountain is Aravali as well as Satpura. These two are very old mountains, right? The first time they were formed, they became mountain. It was in Precambrian time, right? Actually, they are very old when they were young, right? Just like Himalayas. Today, Himalayas are the tallest mountain in the world, right? Because they are young, they are not yet eroded by various geomorphic agents. There was a time when these Aravalis and the Satpuras and even the Appalachians of the United States, which are very much degraded now, they were as tall as the mighty Himalayas, right? But with subsequent time period, they have been eroded. So basically, these are the example. Then there was another phase we call it one we call it Caledonian. I'm sure like you have heard this term in the last lecture. If not, just write it down. Then we call it there is a term we call it Hercynian, maybe Hercynian. And then the present one we call it tertiary mountain building. Or in some books, even in NCRT, it is written as alpine mountain building presently. So like what is Caledonian? Caledonian mountains are like for example Scandinavian mountain, right? The mountain in the Scandinavian countries. They are all example of Hercynian. So their time period was this. Sorry, Caledonian. And the example of Hercynian mountains are they are, like these are all age. Tertiary is age. These are all name of the age. Precambrian is also age, and these are examples. So this is just value addition to you. So Hercynian mountain building, example of maybe Appalachian. Where is this Appalachian mountain located? Where is Appalachian mountain located? It is in USA, right? Mostly in the eastern coast of USA, right? Not in the coast; they are a bit under, but eastern coast, right? So that is. And what is Scandinavia? This is something which I expect you all to know, right? By virtue of your general studies. I hope you are doing you have your atlas and you are doing your mapping, right? Because mapping is very important. Even for prelims, there are questions on mapping, right? So you should do geographical mapping, and you should practice all these places, right? You should be knowing the name of the mountain, all these things. It is very important. So yes, Vivek is saying Finland, Sweden, right? So these three countries, Norway, Finland, Sweden, they are generally known as Scandinavian countries, right? Sometimes they also include this Estonia and Latvia, but they are different. But mostly these three countries, no, Finland, Norway, Sweden, they are Scandinavian countries basically. So what I want to say, I got basically what we were speaking about uniformitarianism. So then these two guys they came that कि they were saying कि जितना इन टाइम पीरियड में माउंटेन बिल्डिंग हो रहा था इनके बीच में the time period in between these not much mountain building was happening. So mountain building was happening, right? But not with the same intensity, right? So the most intense that some processes were intense in some particular time only, right? Some processes they were intense in some particular time period. So intensity differ. This is their addition, right? And if you want me to give some another example, I can give it. Okay, I think this is more than enough. And I hope you understand what is tertiary orogeny. Tertiary orogeny is basically the present day mountain building in Himalayas, in Alps, in Iran, Zagros mountain, even in the Atlas mountain of Africa. So this is all example of tertiary mountain building, right? So this is what they said. Now I'll go through my notes and it will give you more clarity, right? So so you can see, so between until 1750, so between 1600 AD it was all dark ages, right? The much not much scientific development in Europe. After 1600 to up to 1750, what was there? The scientific theory of catastrophism, it was prevailed. So the principle of catastrophism was most accepted view of Earth formation or landform formation, and it says that there is spontaneous catastrophic formation, something like that, right? Not we don't have to go in much detail. Now, what happened after 18th century? A lot of data come up, a lot of industrialization happened, right? A lot of coal and iron got mined out, right? All these things was happening. People were also going in after 16th century. People, especially the Europeans, they started discovering a lot of continent. They started shipbuilding. They started going to long distance and all these things, right? So they got more and more data. Also during this mining cross section of Earth, it was like they basically mined all these cross sections. So a lot of data come up, and here came the concept of uniformitarianism, right? Which in a sentence means present is key to the past. So this could be directly a question in our exam. We will have to write a short note on it. In fact, this is so common a term that it can even be, I think it can someday it could be asked even in our UPSC essay examination, right? So you could be asked, right? You could be asked to write an essay on this. Present is key to the past. So if you will write an essay in UPSC, you will not write geography and geology alone. You will write social, political, right, administrative, legal, ethical, environmental dimension to it also, right? So maybe on this coming Sunday, you can attempt an essay, writing an essay of 600 words on this topic. Present is key to the past, or maybe attempt it in 800 to 1000 words. Present is key to the past from a perspective of a general studies and an enlightened person, right? So this is present is key to the past. So basically, what this uniformitism says, it says that this. It says, I hope this is visible. It says that same processes and laws that operate today, they operated throughout geological time, right? Although not necessarily always with the same intensity as now. So this line was given by James Hutton, and this last line was added by later by Charles Lyell and Playfair, right? So it was given by Hutton, but it was restated by Playfair and Charles Lyell, right? So for example, stream cut valley in the past as they do now, right? The rivers create stream, and like the rivers, they are creating valley. So there is no reason to believe that in the past valleys were not created by these rivers, right? Glaciers of Pleistocene behaved in the same way as glacier operated today. Groundwater always forms sinkhole in limestone as it do now, right? So whatever these processes are doing now, they also did it in the past, right? But the intensity may differ. इसका एग्जांपल आप दे सकते हो ग्लेशियर का. ग्लेशियर वर मोर एक्टिव ड्यूरिंग कार्बोनिफेरस एंड प्लीस्टोसिन टाइम पीरियड, एंड mountain building was confined to certain time period only, like Precambrian time period, Caledonian, Hercynian, and Tertiary. So that is why the intensity differ, but they were present in a way or the other. So this is the first important concept. We have covered two concepts. One is catastrophism. Another one is uniformitarianism. Right. So see, there are some other concept, right? I have included some concept of Davis, which I will explain first. But see, what happens is that in UPSC, in civil science and in forest, they are given some conceptual questions. They are just giving a statement and they are asking you to elaborate on it, right? So when I was studying myself, I search a lot. From where do I get, right? Mostly we generally prepare landforms, which we'll cover in detail. But when I searched through it, and then I realized from where UPSC is asking this. Like, so for example, there was a very famous guy, I think W.D. Thornbury. If somebody from you is from geological background, you must be knowing that there is a very famous book on W.D. Thornbury, right? So in that book, he have given some 18 to 20 principles of geomorphology, right? So UPSC is picking, or maybe 8 to 10 principle of geomorphology, right? So UPSC is just picking one of those principle and asking in our exam, right? So basically the detail of this is also given in Savinder Singh. So you don't have to read all this book, because I have read all these book for you, and I have mined out what is important for our exam, and I have included that in the notes, right? So basically these are some of the principles. So I'll try to explain few of them which could be asked in exam. Some of them are too detailed, too quantitative, which is not important for every exam, but like this is the one, right? Then this is the one. So we'll go through them. This could be asked, and we'll discuss how we can write better answer. Right now, see this one is not given in most of geology book. The question is, little of Earth's topography is older than tertiary, right? And most of it's no older than Pleistocene, right? So अर्थ के ऊपर जो भी सरफेस दिख रहा है हमको, most of it is not older than, जो बिल्कुल टॉप पे है, is not older than tertiary time period, right? So see, I have written it in my handwritten notes, and I have given examples also, right? And in 2021 civil services only this was asked, right? See this paper. This is just this year paper, and I think in this year paper itself they have asked a question. If not this, in maybe in forest services. Now see this question. This third A, what are the concept using geometry? This is normal question. Explain the concept of little of Earth's topography is older than tertiary, and most of it is no older than Pleistocene, right? And although this was an optional question, you could even escape, escape it if you want. But this was covered in our classes also, right? This was covered in handwritten notes. So you just have to explain this, right? These are two three examples, and you just have to elaborate on that, and you would get all the marks. But most of the people were hearing that term for the first time in exam, right? So I'll end the class here, and I'll cover these three four another basic concept in the next